Greetings CEA. This is lesson 3.2.1 Intro to Structural Design. What I'm going to do is as I go through the PowerPoint I will highlight or mark off the pieces that I expect for you to have in your engineering notebook. Alright, first piece of information here. The primary function of a building is to support and transmit the building loads and forces to the ground. Alright, so primary function of a building structure is, you can copy that whole thing down, that's all pretty important there. The point here is that we need to work on figuring out how all of these forces that are applied to a building are going to work their way through the building and then be transferred into the foundation and then from the foundation to the ground. If you were to draw a Venn diagram of the priorities of a structural engineer, you would have three important pieces of it. You want to have a building that's strong enough to hold up all of the dead and live and lateral loads. You also want a building that's stable enough that it isn't going to topple over. But then you want to win the job. And so in order to win the job, you need to make sure that you are efficient in the materials that you use and that you use materials that will take care of the strength and stability issues, but also are economically viable and are going to actually get you the job. Alright, so when we talk about structural systems, we have spent the last bunch of lessons going over all kinds of stuff. Here's a short list of that here, and we're going to look at these all as the smaller structural subsystems. So we have the roof, the walls, the floors, framing, and foundations. And so that's kind of a summary of the last bunch of lessons that we took care of. These subsystems are created using these structural elements. So these structural elements are kind of the tools that are used to put together the floor and the roof and the walls and all of this kind of stuff. We have the beam and column. Those are the two that we're going to focus on the most, beams and columns. We're also going to look a little bit at trusses, and then not so much, but you could use an arch, a vault, or a dome. Two definitions here. First, force is something that you should be pretty familiar with. Any action that causes a change in the shape or motion of an object. And then a load is a special type of force. And it's a force that's supported by a structural element. And so as we go forward with the lessons in this unit, we're going to talk more about about loads. These here should be familiar to you. Tension. My recommendation is that you actually just sketch this. I know for myself that sometimes just seeing that visual is a little bit more useful than writing out a bunch of words. So tension is when you pull on something. Compression is when you push it together, and so these are axial forces. The force is exerted along the axis of the member. Shear is the one that you might not be as familiar with. Probably the easiest way to envision it is to think of a pair of shears or scissors, and if this was a thin piece of balsa wood and you had a big strong pair of scissors or shears and you were cutting it, the force would be exerted kind of like this by the two blades of the shears. So that's kind of what a shear force looks like. It's perpendicular to the axis of the member, causing the internal particles of the member to slide against each other. Alright, a few more definitions here. Beam. Beam is a structural element that carries a load that is applied transverse or perpendicular to its length. So the purposes of this class, we are going to assume that beams are going to be horizontal members, and the load is applied transverse to its length, and because of how that's happening, the top of the beam, the top half of the beam, is going to be in compression. So the top is in compression, and the bottom of it is going to be in tension. And this is actually an important part of a design, this last bullet here, because if you were the structural engineer and you had to figure out where to place the rebar, if this beam is primarily going to be loaded like we're seeing here, then it's important to put the rebar in the lower half, because the rebar is what's going to accommodate for concrete's relatively low failure in tension. All right, cantilever is a special type of beam. Cantilever is a beam that at one end is fixed. So not only is it resisting motion in the X and the Y, but it's also going to be resisting a moment. So it's going to be fixed here, so it can't rotate up or down. When you apply the force, you'll notice that the compression and tension are opposite from just the regular beam that's supported at two ends. You'll notice that in the top you have some tension and in the bottom you have compression. So if you were making a concrete slab that was going to be fixed at one end and cantilevered, you would actually want the rebar to be in the top half. We're also going to look at columns. We need to have this common language so that when we talk about a beam or a column or a girder, that we're all thinking about the same thing. So for the purposes of this next bunch of lessons, columns are always going to be vertical, and we're going to assume that the loading of the column is along the axis of the column. So it's axially loaded, and we're going to assume that that loading, because of gravity, is going to be in compression. All right, we're not going to worry too much about these columns being in tension, although there are cases with uplift and with some different forces where that may happen, but for purposes of this class, it's going to be pretty safe to assume that they are in compression. All right, so you have studied trusses in Principles of Engineering, and trusses are we had a bunch of basic rules when you did Principles of Engineering. So some of those rules included the fact that all of the joints in a truss are pinned. We also assumed, so these are the assumptions that we made, we also assumed that each member is either in just tension or compression. We're not going to worry about shear or torsion or any other crazy forms of forces that might be happening to them. We're also going to assume that the force, the loading on the truss is always at the joints. All right, so those are the assumptions that we'll keep in this class, although we're not going to go deep into trusses over the next few lessons. So this here should be reviewed from a little bit earlier this semester. You have these arches, they're curved structural elements, and the top of them is a keystone. We're not going to study them structurally too much further than that. You also have a vault, which is basically someone decided to make an arch and then they just got carried away and they just kept on building and building and building, and it became sort of a what's called a vault, or like a bit of a hallway. And then the dome is also based on the arch, but the pattern's repeated radially. All right, so we're not going to spend a whole lot of time on those, just pointing those out, that those are other ways to structurally support things. And then this slide is just telling you that in reality, you probably have a whole pile of different structural subsystems working together, and structural little elements working together. So here's a bunch of trusses, and then it's a dome, and some beams, and all kinds of different stuff all working together in these examples here.